Hi everybody. So in this video I want to talk to you about transistors, and in particular how we can use transistors as switches to control large currents. So to illustrate the problem that we're trying to solve with the transistor switch, let me pose the following situation. So let's say we have our Arduino board. So here's the Arduino. And we're using one of the output channels here. And we want to drive a motor. And the way this motor works is when there's 5 volts on the motor, it of course sends current through the motor and the motor spins. Now, we could think about how much current the motor uses if we know the resistance. And the resistance of a lot of these little DC motors is on the order of 10 ohms. So using Ohm's law, current is equal to the voltage divided by the resistance. The voltage is 5 volts. The resistance is 10 ohms. So this gives us something on the order of half an amp or 500 milliamps. And if we were to power the motor off of the 5 volt supply, this wouldn't be a problem. But if we try to do this off of one of the output channels, we run into some issues. In particular, the Arduino channels have a 25 milliamp sort of typical max value that you'd like to use. You can go a little bit higher than this, but 25 milliamps is sort of a good rule of thumb not to go above that. And so what we need is we need a way for this small current from the output channel to turn on a larger current through the motor. And that's where the transistor switch comes into play. So let me clear the board here, and we'll look at a analogy to the transistor, which is a garden hose valve. Okay, so here we've got a picture of a typical garden hose valve. So you can see the green hose on either ends of the valve. And the valve has essentially 2 positions. We can turn the valve on so that water can flow through the valve, or we can turn the valve off so that no water is able to flow through at all. So this is exactly what we want our transistor switch to do. We want to have a small control current basically turn that valve on and allow a larger current to flow through. So transistors are 3-terminal devices, and here's a picture of a transistor. And what the circuit symbol for a transistor is, it looks like this. And we can name the different terminals. We've got the base, we've got the emitter, and we've got the collector. And the way this works is the base acts kind of like the valve on the garden hose. And so when there's some current that runs into the base, it opens the valve and allows current to flow freely from the collector to the emitter. So let me show you a typical way this would be wired up if we were going to drive the motor, and we'll talk a little bit more about the operation of the transistor. Okay, so let's sketch out the transistor here. So without labeling the different pieces, we've got the base, the emitter, and the collector. And what you usually do when you're using a transistor as a switch is we send the emitter to ground, and we'll put our device in between 5 volts and the collector. So this would be our motor. Then there's usually a limiting resistor at the base, and this would be the control signal from the Arduino. And a good value for this is like 220 ohms, the same value we use typically for the LEDs. So let's talk about what happens here. So when the Arduino signal is 0 volts, no current's going to flow into the base, and so the valve is off, and so no current flows from 5 volts to 0. If you think about this is like the garden hose, and this is the valve will be off when this is at 0. When we turn the Arduino channel on, we turn it high, so there's 5 volts here. There is a current that can flow in through the base and then through the emitter back to ground. So a current will flow through this way. When that current flows through, that has the effect of turning the valve on, and now current can flow through like this. Just like when you turn the valve on the garden hose, water can flow through the hose. So when we turn the Arduino on, a very small current flows from the output channel because of this limiting resistor, but that small current allows a large current to flow from the 5 volts through the motor and back down to ground. Now there's one other little feature that we have to add typically when we're driving motors, and that's a protection diode. So what happens is if we turn this on, current flows through the motor, but then if we turn it off, that's going to try to pinch off the current so that and stop the current through the motor. Now because of the way the motor is made, it wants to keep current flowing, and so if you suddenly turn that off, it can develop some fairly high voltages here and actually damage the transistor. So you need some place for that current to go when you turn off the transistor, because the current through the motor doesn't like to just stop on a dime. And so this is where you can add a protection diode. So a diode is a device that current can only flow in that direction, the direction of the arrow. Now we've actually already met diodes when we've looked at light emitting diodes. Remember, light emitting, or LEDs stand for light emitting diodes, and they only allow current to flow in one direction. So that's exactly what we're using here. So the way this works, when we turn the base on, current flows from 5 volts down to ground, but because the diode's pointed this way, it can't flow through the diode, so it all flows through the motor like we want. But then when we turn it off, the current flowing through the motor has a place to go. It can flow around in a circle like this for a second while it bleeds off. So this is the basic setup of the transistor switch, in particular transistor switch wired to power a motor. So walking through it one more time. Turning on the Arduino channel sends current from the base through to the emitter back to ground, limited by the 220 ohm resistor. That current is going to turn the transistor on, so current can flow from 5 volts through the motor and back to ground. Can't flow through the diode because the diode's pointed up. When we turn the Arduino off, no more current flows through the base, so the valve is turned off and there's no current that can go through the transistor. The motor doesn't like that, but it's got a path now that it can send that current around like that. So let me show you what this circuit looks like in the real world, and we'll try to power a real motor with a little fan blade on it. Okay, so here's what the circuit looks like in real life. So the whole goal of this circuit is to drive this motor. So let's take a look at what we've got. So to start off, of course, we have our power coming from the Arduino going to the positive and negative power rails. Then I've got our transistor here, this little black dot, and it's got the flat part facing towards us. So we've got the emitter, then the base, and then the collector of the transistor. The emitter of the transistor is connected to ground. The base is connected to this 220 ohm resistor that goes across the trench, and then this red wire is connected to the other end of the resistor and goes into channel 12. This is where we will give the control signal to turn the transistor on. The collector, I'm just using a yellow jumper wire here to jumper it over, and then I've got my diode facing that way, so current can only flow through the diode in that direction. And then on either side of the diode I have the wires coming from the motor, and then on the other side of the diode in the motor I've got this red wire going to power the whole thing. So when the channel 12 goes high, it's going to send current through the resistor, through the base, down to the emitter, and that's going to allow current to flow from this 5 volts through the motor and then back to ground, turning this switch on, just like the water valve we were talking about earlier. Let's take a look at the code. The code's essentially the same thing as the blink code we did in one of our earlier videos, but let's look at it. We've got pin mode 12 as an output because we're using channel 12 as an output. We're going to write channel 12 high, then we're going to wait for 2 seconds, then we're going to turn it off, and then we'll turn it back on. Again, this is just sort of an example code, not really doing anything particularly interesting just yet, just showing you how we can control the motor, turn it on and off from the Arduino. So I'm going to go ahead and plug the board in, and let's see what this looks like. Okay, so I've turned the board on, plugged it in, and I've also added this little fan blade to the motor so it's easier to see when the motor turns on and off. And you can see now that we're able to drive this motor, which requires a lot more current than the Arduino channels can provide, with a control signal from those channels. Remember, that control signal is turning that transistor on and allowing the larger amount of current coming from the 5 volt power supply to flow through the motor. So this is a really important circuit that you can use for all sorts of things when you want to control a device that requires a lot of current with a device like the Arduino that can only output a very small amount of current. So neat little circuit, and we'll definitely use this in some later projects.